So here are the practice problems from section 4.2. I'll just kind of walk you through how I got the solutions that I did and how they work. So hopefully this will give you a better understanding of this section. So our first problem, we had the square root of 2, or 2 square root 3 plus 10 square root 3 minus the square root of 3. We treat this problem very similar to like if these were all variables, so like 2x plus 10x minus x. And we basically just combine the like terms in a way. So since these are all the same, that's what we can do. So we combine the outside numbers. 2 plus 10 minus 1 gives us 12 minus 1, which is 11. So your solution is going to be 11 square root 3. So again, like this is just like an x, same situation. Okay. If we go to the second example, if you notice, these are all different now. And that's where that simplifying of radicals is going to come into play that they talked about in this section. Because your goal is to try to make these, as many of these the same as you can so you can combine things. And sometimes you can't, and that's okay too. Okay, so to simplify them, if I take a look at the square root of 8, what we need to do is break this down into two pieces if we can't take the square root of 8. One number, or I should say the two numbers need to multiply to give you 8. One of which you have to be able to take the square root of, okay? If you can't find a number that works, then you can't simplify the root itself, okay? But this one does, because 4 is a number we can take the square root of. 2 we can't. So if I do square root of 4, that gives me 2. And then we keep the square root of 2, okay? With the square root of 16, that's one we can do, so we're just going to write that as 4, okay? Then I'm going to rewrite this, replacing my different roots, these last two, because the middle one, there's nothing we could do to it. So I'm going to replace these with what we got here, remembering that I still had these front 2's here. Okay, so here I have that 2 from before, and I replaced the square root of 8 with 2 square root of 2. Kept the middle term. Here I had the 2 from before, and I kept the 4, or I replaced the square root of 16 with 4. So now, you can multiply these two outside numbers, keeping this root the same. So this gives us 4 square root 2. This is still the same, and here 2 times 4 is 8. And now we can combine these two together using that same thing we did over here. 4 minus 4 gives me 0, so that cancels, and we're left with just 8 as our solution. Okay. Next one is very similar to this, where we have to try and make these the same as we can. Okay. So square root of 5, there's nothing we can do with that because that's just a prime number. Square root of 125, we can do something to, and the square root of 25, we can do something to. Okay, so I looked at square root of 25, went through my numbers, and my largest square number that I can take, or number that I can take a square root of that multiplies into 25 is 25. 25 times 5 gives me 125. So we rewrite that as 5 root 5. So square root of 25 is 5, keep this part. Square root of 25 is just 5, so I'm going to replace that. Okay, so the square root of 5 comes down. This changes into 5 square root 5, and this is just a 5. Remembering to keep our symbols the same. So here's subtraction, here's addition. Then we combine these together, so it's like doing a 1 minus a 5 to give us a negative 4. So that gives me negative 4 square root 5, and we bring that 5 down. Now there's something called standard form that goes with numbers like this where we can't put them together if we have a square root and a non-square root. And usually what you do is you put the regular whole number in the front, the number with the square root in the back, so you just switch them. So your solution then is going to be 5 minus 4 square root 5. And there's nothing else we can do. We can't put these together because this has a root and this does not. Okay, so that's the addition and subtraction problems. Next was a multiplication problem. So what you're going to do is basically the opposite of what we did when we simplified up here. And we're going to take that 5 and we're going to multiply it times the 80. Okay, so we put them together underneath one root. 5 times 80 gives me 400. 400 is a number you can take the square root of, and our solution is just 20. Okay, if it was not, we'd have to do that simplifying process like we did up above. But because we can take the root of it, we're just going to leave it as 20 as our solution. Okay, and the next problem that they have looks like this, where it's got a square root of 6 on the outside, and then 7 plus square root 2 on the inside, and what we're going to do is we're going to distribute them. Okay, so when I distribute the square root of 6 to the 7, sorry, got blurry there. What's going to happen is the 7 is going to switch to first, and that square root is going to come second. Then we're going to keep put these two together underneath the root like we did in the last problem. Okay, so 6 times 2 gives me 12. Nothing we can do about this guy here. 6, there's no numbers that go into it that you can take the square root of, so there's nothing we can do with that part. 12, though, can be broken down into 4 times 3, because we can take the square root of 4. So that 4 becomes 2, and we keep the square root of 3. And then if we add them together, there's nothing that we can do to simplify this anymore, because we can't break down that 6, and we can't break down the 3, so this is our solution. Okay, and the last one here, same thing as the last one, square root of 3 times 3, square root of 3 times negative square root of 3. This one's 3 square root of 3, just like in the last one. We kept the number, we put the whole number on the outside. Here we put them together underneath the root. Okay, so then we have 3 square root of 3 stays the same, minus the square root of 9. 3 times 3 is 9. Square root of 9 is just 3. So we have 3 square root of 3 minus 3, which we cannot put together because no root, or I should say no root and a root. And then we just switch them into their standard form. So hopefully this helps. Email me if you have more questions. I'll see you on Tuesday. But good luck.